Hi guys, this is Miss Gariano. I just wanted to take the time and make a video to help kind of go over what we investigated today in class about 45, 45, 90 triangles. So these triangles are at their essence a right triangle. So they have this 90-degree angle here. And they are isosceles, meaning these two side lengths are congruent. What that tells me about these angle measures, if this one's 90 degrees, since it is a right angle, the two base angles here have to be congruent because it's isosceles. So I know that 90 plus these two angles, which are congruent, have to add up to 180 degrees because the angles of a triangle, their sum is always 180 degrees. So I know that 90 plus 90 will give me 180 degrees. So half of that, it's already covered by this right angle, which means the sum of these two angles, let's call it angle 1 and angle 2, I know that 1 plus 2, that is angle 1 and 2, not really, because 1 plus 2 is actually 3. But I know that these two angles have to add up to 90 degrees, because that's the only way this whole triangle is going to add up. But 1 and 2 are the same measure. So this is really like we're going to take this 90 degrees left over and split it in two. So we know that these two angles are actually 45 degrees. So we know these two angles down here are 45-degree angles, which is why this triangle has a special name, the 45, 45, 90-degree triangle, because those are the angle measures of this triangle. So we want to, well, what we did in class is we investigated the relationship or ratio of the side lengths. But I kind of want to look at it from a slightly different aspect. So we know that these two side lengths are equal. So to kind of create a scale factor that's going to be easy, I'm going to say let's let this distance be 1 and this distance be 1 because they have to be equal, right? Because we could use dilations, which will keep all the angle measures the same, so we'll still be working with a 45, 45, 90 degree triangle, but we can scale it up by anything we want. If I want to make the side lengths here 3, I just multiply everything by 3. If I want to make them 1/2, I multiply by 1/2. If I want to make them, 1.5, I multiply by 1.5. So it's more versatile if I just let these be 1 for right now. But we want to find out what is the length of this hypotenuse here if these two are 1. Well, we can use our Pythagorean theorem to figure that out. So we know that 1 squared plus 1 squared has to equal, let's let this side be, let's go ahead and let it be c, because that's the Pythagorean theorem. That's going to be c, so it's going to be c squared. Well, 1 squared is just 1, and 1 squared is also just 1, so that'll equal our c squared. Last time I checked, 1 plus 1 is just 2, so that is equal to c squared. Now I have a squared number here, and the only way to undo a squared is with a square root. So I'm going to square root both sides. Now it's important to remember this really introduces a plus or minus here, but when we're talking about side lengths, we really only care about the positive answer because there are no negative distances. So we don't have to write a plus or minus when we're talking about lengths, as long as you know that and know that we're purposely excluding the negative answer. So this tells us that we get the answer of square root of 2 for c. So C equals the square root of 2. So the relationship of the side lengths of a 45, 45, 90 triangle is the two legs, the two equal legs of our isosceles triangle are in a relationship of just 1. They're the same length. And then our side here is the square root of 2. So we can adapt this slightly. We can say instead of having this be the length of 1, we could say that is the length L, right? Because that's like just a variable that tells me that's the length. Well, that means that this side also is L, which makes this side, the third side, C. Instead of just square root of 2, it's going to be L times the square root of 2. So the relationships of the sides of a 45, 45, 90 degree triangle are in the relationship of L to L to L square root of 2. We might write that as L times the square root of 2. So this works for anything that's a 45, 45, 90 degree triangle. So if we know side lengths, we can easily figure out what a missing side length is. So let's look at an example of that. Here we have a 90 degree isosceles triangle, which really means that this is a 45, 90 degree triangle. So let's assume, or the problem in this problem, let's assume that this side length here is 9. And we want to figure out the hypotenuse length, which is x. Well, we can use this ratio over here. We know that if the side lengths are a given length L, that the length of the hypotenuse will be that L, that distance of the side, times the square root of 2. So that tells me that x is going to equal our 9 times the square root of 2. And it's as simple as that. Alright, well, let's try something slightly different. Let's say that they tell us that the length of our hypotenuse is going to be 2 square root of 2. And we want to figure out the length of the sides here, which both are x. Well, we know that it's going to be the length times the square root of 2. So we can say the length is going to equal length times the square root of 2. Well, we know that our length here is x, and the hypotenuse here, which is this side here, right, these correspond, is 2 square root of 2. So this L here matches up with the coefficient, or the whole number multiplying the square root of 2, which means x has to equal 2 square root of, or it has to equal 2. So we know that x is going to be 2, because we can take this 2, multiply it by the square root of 2, as we see in this ratio, and we get 2 square root of 2 for the hypotenuse. Alright, let's look at one more example, a third example. Let me reset our triangle here. So let's look at a triangle where we want to find the length of the leg, so this x, but our hypotenuse is now 6. So it doesn't have that square root of 2 hanging around. Well, we know from this ratio that the length is going to be the same as the length times the square root of 2. Right? So length times square root of 2. That hypotenuse distance has to be 6 according to our problem. So we know this equals 6. And we also know our length is given by the variable x. So we get x times the square root of 2 equals 6. So in order to solve for x, these are two things multiplying. The way that we undo multiplication is with division. So we're going to divide by a square root of 2 on both sides. So we get x is equal to 6 over the square root of 2. And I am perfectly happy with you guys leaving your answer like this. Or we can use our calculator to get a decimal approximation. So this is also approximately equal to, hold on here, getting it in my calculator, 4.24. So that tells me that the leg length here is equal to, or approximately equal to, 4.24. So that's how we figure this out if we are not given a hypotenuse length that includes our square root of 2. We just have to divide this by our square root of 2. So I hope this video is helpful, and I will see you on Monday.